right, first of all, we have a trough. Does anyone know what a trough is? Sort of a long shape that you could put liquid into. Often use the word for like animals when they're eating out of a long thing. In this one, we're going to have one that is 10 feet long with an isosceles triangle as beautifully drawn. So it is triangular like that, so you could pour a liquid into it this way and fill it up. So we have a trough that's 10 feet long, and it has an altitude. Altitude is a mathematical word. In a triangle, the altitude is the same as its height. So why don't they just use the word height? Good question. And a base of 4. So this part here is 4. Altitude of 3 and a base of 4. And the vertices are at the bottom. If water is poured into the trough at a rate of 3 cubic feet per minute, so that is change in what over change in time? Change in volume. And so we know that volume is a function of time, and it's changing at 3 cubic feet per minute. How fast is the water level rising? So we're trying to find change in height over time. So that tells us that the height of the water is also a function of time when the water is 1 foot deep. So this is what we're trying to find when h is equal to 1. So first of all, we have to recognize that our trough is a geometrical shape. It is a triangular prism, and we have to know how to come up with a formula for the volume of a triangular prism. And it's the same idea that we saw yesterday with the cylinder. You know how with the cylinder I said you just keep cutting out circles until it gets to the top? If you stand this one on end, you would just have to keep cutting out those triangles until you get to the top. So our volume formula will just be the area of the base, which is 1/2 base times height, because that's the area of a triangle, times by the 10, because it's 10 feet long. Problem with this formula right now, as far as doing the next step? There's the 2 variables. So we need to somehow come up with a way to write this only in one variable. In particular, since we want to find dH dt, we would like to write it only with the variable h. Now some people say, well, I know that the base is 4 and the height is 3, but that would only be the case if the trough were completely full. So I'm going to draw this triangle again here, where the base is 4 and the height is 3. And what's happening is we're looking at a situation where the water is at 1 meter. And if it's 1 meter high, the base and the height aren't going to be 4 and 3. We could find out what they are at that point, but that doesn't help us with the formula. The thing I want you to notice, though, is this large green triangle. What does that have to do with that triangle right there? They're similar triangles. One is going to be a factor of the other one. They're going to have the same ratio of all their sides. So what's happening every single time is our ratio of our base to our height is always going to follow this ratio. Couple of ways you can look at it. If you're looking at ratios that way, okay, that the ratio of the base to height is 4 to 3. If you wanted to make them equal, does it make sense if I wanted to make them equal, I would have to times the base by 3 and the height by 4? Because right now they're not equal. One's 4 and one's 3, but that's the ratio that they're in. If I wanted to make them equal, that 3 bases would equal 4 heights. One way to come up with an equation so that you can work with it. The other way that you can work with equations is you can think of these ratios as fractions. B over h has to be the same as 4 over 3. And if you use those ratios as fractions, you can see where the multiplying across would come out, and you would get 3b equals 4h. Either way, we can solve for b, that is 4/3 of the height. So we need to use these similar triangles off to the side so that we can take our volume formula. I'm going to take the 1/2 and the 10 and make that a 5. Instead of the b, I'm going to write 4/3 h times by h. Simplifying this further, I'm going to get that my volume is 20 over 3h squared. Now I've got my volume formula in terms of height only. Now I can take the derivative with respect to time of the whole thing. And we'll get dv dt is equal to 40 over 3h to the 1 times dh dt. Implicit differentiation with the chain rule there. I'm going to erase my little one because it almost looks like h prime. And now we want to find it when the height was 1. We want to find our change in height with respect to change in time. And we know that dv dt was 3. Thank you. So 3 equals 40 over 3, plug in the 1, dh dt. Multiply both sides by 3 and divide by 40. 9 over 40, leave some space for units. Feet, was it per second or per minute? Feet per minute. That's the rate at which this trough is being filled. At 1 meter. So at that instant, at 1 meter, this is how fast the height is changing. So if you wanted to wait 1 more minute, you would expect it to go up this much. If you waited 2 more minutes, you couldn't use that over a long period of time because it's always changing. But it would give you an indication of what you could expect over the next minute.